EIGRP pass metric calculation. In this video, I am going to talk about the parameters, the features related to the metric calculation in the EIGRP. Okay, also let me to emphasize that about the metric calculation in EIGRP, we have some differences between the classic EIGRP configuration and also the named EIGRP configuration. In the first step, I will talk about the a classic metric calculation, and after that we will learn about the named metric or named EIGRP metric calculation. Okay, let me first talk about some of the features, some of the for example criteria that in EIGRP we are using for calculating the metric. Look at here we have a simple scenario. I have configured this scenario before, and as you can see, I'm going to use this scenario for the EIGRP pass metric calculation explanation. Okay, let me first start about the parameters that we are using for calculating the metric. You know that for each interface, okay, we have some parameters. For example, one of the parameters that we have for interface is the bandwidth. Okay, and what is the bandwidth? The bandwidth means from this interface how many bits can be sent in 1 second. This is the bandwidth. Okay, let me to show you some of the bandwidths that we have, for example, in interfaces. You have learned about the bandwidth previously, but now let me to show you some of the interfaces bandwidth. For example, in the router 4, this is the fast Ethernet 00. Let me to show you. This is the fast Ethernet 00. The show IP or show interface fast Ethernet 00 can show us the bandwidth of this interface. Fast Ethernet means 100 megabit per second. 100 megabit per second means 100,000 kilobit per second. Okay, because of that, let me to write here, because maybe we will use them. Okay, we know that about the bandwidth. This is the bandwidth. Okay, about the fast Ethernet, we have 100,000 kilobit per second, means the 100 megabit per second. And about the serial interface, okay, let me to show you the bandwidth of the serial interface. Show interface, okay, serial 10. As you can see, the bandwidth of the serial interface is 1544 kilobit per second, or 1.5 megabit per second. Let me to write here 1544 kilobit per second. Okay, and you know that we can change the bandwidth. How? Look at here, with one simple command on the interface, you can change the bandwidth of the interface. Router config if the command is bandwidth, okay, and then you can configure the bandwidth. Don't forget that this bandwidth is assumed with the kilobit per second unit. For example, when you want to configure bandwidth of the serial 11 of the router 1 as 1200 kilo, you should configure bandwidth 1200. That's it. Let me to show you. In the R1, I have configured the bandwidths before. Show run interface serial 11 can show us that here we have the command bandwidth 1200. Maybe you ask me, this is the real bandwidth or not? No, this is not the real bandwidth. This is the bandwidth we are informing to the EIGRP or some other tools that are using the bandwidth. Okay, actually with the bandwidth command, we are saying we are informing the EIGRP that this interface has the bandwidth of 1200 kilo. Okay, this is our information that or the EIGRP or some other tools information for their jobs. Okay, after that, let me to talk about the next parameter that we are using for bandwidth for the metric calculation in the EIGRP. The name of this parameter is the load. What is the load? Load is the amount of traffic that we have on one interface. You know that normally on one interface we can have for example from 0%, okay, 0% to 100% of the load. Okay, 0%, 100%. But actually the minimum amount of band traffic that we have on one interface, because the interface is enabled and this interface is not off, is 1%. Okay, or maybe less than lower than the 1%. In the iOS, we don't use the percentage. Look at here. Percentage means 1 over 100. Okay, 1%. To the 100 over 100 means 100%. Okay, Actually, in the iOS, we are using as for the load, the minimum value as 1/255, okay? And for the 100% means maximum load, okay? Full load, 255/255, okay? Look at here. In the show interface serial 10 or show interface fast Ethernet 00, you can see the load of interface. TX load means transmit load. RX load means receive a load or a ring load. As you can see here, because we don't have any traffic, this is the minimum load that we have, 1/255, and again 1/255. Okay, we know about the load now. After that, we have another parameter in EIGRP, we call it the delay. Delay is the latency or delay of that interface, and the delay of interface, when the delay of interface is high, okay, this means that the bandwidth of that interface is low. Why? Because for sending the traffic we need to wait more, because of that the bandwidth, that means the amount of traffic that we can send in 1 second is lower. It is obvious. Okay, for example, about the fast Ethernet, because fast Ethernet has high bandwidth, we expect to see the low delay. Look at here in the R4, let me to show you show interface. Okay, fast Ethernet 00. Here you can see the delay of the fast Ethernet is 100 microsecond. Okay, 100 microsecond is the we can assume that this is a low value, or this is not so high value. About the serial interface, let me to show you the amount of delay. Again, you can use the show, okay, interface, show interface serial 10. As you can see here, the delay of the serial 10 is 20,000 microsecond. Means here we have more delay than the fast Ethernet, and this is obvious. 20,000 microsecond. That's it. This is the next parameter that we are using it for the calculation of the metric of EIGRP. Don't forget, if you want, you can configure the delay of one interface router. Config if with this command delay, okay, then amount of delay. You can configure the delay, but don't forget that when you are configuring the delay, the unit of this delay is 10 microsecond. What does it mean? It means that when you are configuring delay 10, means actually you are configuring 100 microsecond. Or when you are configuring 1000, means the delay is 10,000, okay? After that, maybe you ask me, the delay is a parameter related to the physical structure of one interface. How we can configure the delay? Again, I'm going to emphasize that this is not the real delay. This is the value of the delay that we are informing to the EIGRP. Okay, the next parameter that I'm going to talk about that we are using for the metric calculation in the EIGRP is the reliability. What is the reliability? First, we should understand the reliability. You know that in one interface, okay, we are receiving some packets. Look at here. Assume that here we are receiving 3 packets. This is the packet 1, okay, and this is the packet 2. In packet 2, we have some noise. Let me to write here. This is the packet 2 with some noise, and after that the packet 3 without any noise. Assume that we are receiving these 3 packets on the interface of router. The first packet doesn't have any noise, but when this packet is receiving on the interface of router, because some of the misbehaviors of the interface or some problems related to the interface, this packet is dropping. Okay, this is possible. Because of that, the first packet, okay, now is dropped. This is the story about the first packet. After that, about the next packet, because of the noise, the router interface should drop this packet. But the third packet is a noise-free packet, and also the interface can receive it. Because of that, now here about the for example, third packet, we don't have any problem. Actually, from the 3 packet, now we can accept, we can receive only 1 packet without any problem. And actually we can say the reliability of this interface is 33.33%. Okay, this is the reliability. The reliability is the ratio of the correct packets over the all packets. Okay, or the okay packets over the not okay packets. Okay, because of that, about the reliability, the worst case is we have the reliability of 1/255, and this is the minimum reliability and most, for example, the most worst case of the reliability, and the best reliability, maximum reliability, is 255 over 255, means the 100%. Because of that, in the interface, if you check the show interface serial 10 or other interfaces, you can see that the reliability by default is 255 over 255, means we don't have any problem. As you can see here, now we can understand the bandwidth, delay, reliability, and also load. Okay, now let me to talk about the formula of the EIGRP classic configuration. You know that in EIGRP we have two types of configuration: EIGRP classic and EIGRP named. Okay, first let me to talk about the named configuration. You know that in EIGRP we are using these parameters for calculating the metric for one pass. For example, R1 receiving the information about the 10400 from the router 2 and also from the router 3. Okay, now R1 should choose which pass is the best. Okay, the R1 is using this formula for calculate the metric. Okay, as you can see, this formula contain the bandwidth, contain the load, contain